Welcome to the warm thermal energy storage validation site of the pump heat projects at KTH Stockholm, Sweden. Latent heat thermal energy storage materials, known as phase change materials, are tested here for their high thermal energy storage density and small phase change temperature variation. Here we're looking at two thermal energy storage units with a capacity of 540 liter and 380 liter. We have performed tests on two types of phase change material encapsulations and one submerged coil heat exchanger. To my left is shown ellipsoidal type of encapsulation. To my right is shown the slab type of encapsulation that we placed inside the tanks. And here in my hand is shown one of the 40 layers of coils that we have in the submerged tank design setup. The submerged coil heat exchanger setup in the tank presents high phase change material packing factor, but low thermal power rating, while the encapsulated design has lower packing factor, but much higher thermal power rating. We use here ATP 60 and Crodatherm 60 as the phase change materials that have suitable temperature range for our application. The operating temperature range lies between 46 degrees Celsius and 72 degrees Celsius based on an integrated design of a combined heat and power plant in Moncalieri, Italy. Here the goal is to store low temperature waste heat and bring up the temperature level with a heat pump for injection into the district heating network when the need arises. The flow rate tested in this specific setup ranges from 150 liter per hour to 500 liter per hour. Water is used here as heat transfer fluid. We obtain from the different thermal energy storage designs around 60 kilowatt hour per cubic meter of storage capacity. This is 50% higher as compared to sensible hot water storage system. And we obtain around 30 kilowatts per cubic meter of thermal power rating. The results obtained from the test campaigns are used for the numerical model fine-tuning and final demonstration prototype design. The results are useful for future analysis and the upscale design for future work. The validation site test results have been successful, and we are grateful for the Horizon 2020 funding.